Hi everyone, this is task 3 of tutorial 8 and we are back to solving the midterm. So we were given a matrix here and we have to decompose it into an upper triangular and lower triangular matrix. And then we have to also find out the inverse of the matrix. So we're given a 2 by 2 matrix here and we have to find out the upper triangular and lower triangular matrix. So here the only element that we have to make to 0 is just this element here. So this is L21. So first let's find out what is L21. L21 would be, after freezing the first row here, so L21 will be A21 divided by A11, which is 1 divided by 8. So the equation that we need to write for this row here now would be row 2 minus L21, which is 1 over 8 times the row that we freezed, which is row 1. So let's work it out. And this would give us the matrix as 8, 7, 0, 1.125. So that's our U. And to write the L, the lower triangular matrix, we know that the diagonal will be zeros, above them will be, the diagonal will be ones, and then above that will be 0. And this element here is L21, which we already have got the value of, so it's 1 over 8. So this is very simple because it's a 2 by 2 matrix. We only have to work with one element. Now for the second part, where we have to find out the inverse of A. So now we have to find out the inverse of A. So let's say that A inverse looks something like this one here. So B 1 1, B 1 2, B 2 1, and B 2 2. And let's say that the identity matrix looks something like this here. So it's a 2 by 2 matrix, so it's 1 0 0 1. We know this matrix, and we also know that for every column here we will use the column here, right? So let's name this one here as column 1 vector and this one here as column 2 vector, and let's say this one here is x1 vector and this is x2 vector. Now if we start our workout for the inverse, we have to follow two equations, that is L times Z, an unknown vector. So it's the lower triangular matrix times the unknown vector is equal to the identity matrix column 1. And then we will work out with the upper triangular matrix times the unknown vector x1, and then we'll equate it to the z vector that we got from above. So let's go ahead and start working on this one here. So the first thing we'll do is L times Z is equal to column vector 1. So we have our L is 1 over 8, 0, and 1. And Z, or we can write as Z1 and Z2. And the column vector 1 of identity matrix is 1 and 0. So here, now if you solve, you'll get 1 times Z1 plus 0 times Z2 is equal to 1. So we have here, so this is 0, and 1 times Z1 is Z1 is equal to 1. So we got the value for Z1, and then working on the next equation, we have 1 over 8 times Z1 plus 1 times z2 is equal to 0. So we know the value of z1 already, so that's 1. So z1 is 1. 1 times 1 over 8 is 1 over 8. So we can say z2 is 0 minus 1 over 8. So it's minus 1 over 8. So that's the value for z2. And once we got these two values here, we can work out now u times x1 is equal to z. So we'll take the upper triangular matrix now, which is 8, 7, 0, 1.125 times the first column, which is b11 and b21, is equal to z vector, which is z1 is 1 and z2 is minus 1 over 8. So now we'll get here 0 times b11, so 0 times b11 plus 1.125 times b21 is equal to minus 1 over 8. So that gives us, this is 0 itself, so b21 is equal to minus 1 over 8 divided by 1.125, which will give you the value as minus 1 over 9. And then we'll have here the second equation, which is 8 times b11 plus 7 times b21 is equal to 1. So now if you replace the value for b21 with minus 1 over 9, you will get the value for b11 to be equal to 2 over 9. Next, so we got the values for the first column of the inverse of A, and now we have to find out for the second column for the inverse of A using the same process that we just did. So again, we'll go back to using the lower triangular matrix times unknown vector z is equal to the column 2 vector of the identity matrix. So L is 1 over 8, 0, 1 times z1 and z2, and then we have here column vector 2, which is 0 and 1 of the identity matrix. So if you solve this just like how I showed before this, with the backward substitution, you will get z1 is equal to 0 and z2 is equal to 1. And then we'll use u times x2 this time, so that we're finding that the second column of the inverse is equal to the z. So u is 8, 7, 0, 1.125 times b12 and b22 is equal to vector z. z1 is 0 and z2 is 1. So if you solve this with backward substitution, you will get for b12 the value as minus 7 over 9, and for b22 we'll get the value as 8 over 9. So now if you want to represent a inverse, so we'll put the values of b11, which is 2 over 9, then we have b21, which is minus 1 over 9 that we received in the previous page, the values, and then here we have b12 minus 7 over 9, and b22, which is 8 over 9. So that's the inverse of the matrix A.